Hello, my name is Katherine Rutherford, and I'll be presenting the Module 9 readings as part of my annotated bibliography. The theme of this module is evaluation of computer-human interfaces. The first reading that I'll be presenting is from the required reading Handbook of Human Factors and Ergonomics in Healthcare and Patient Safety, and it's the usability evaluation in healthcare. So this chapter focuses on the importance of human factors evaluation in the healthcare delivery system and the role of healthcare providers in usability testing. The authors go into the different areas that human factors evaluation can be incorporated into healthcare as well. The two focuses of usability testing or human factor evaluation are usability testing and heuristic evaluation. So the difference between the two is that usability testing uses actual end users who perform the tasks and the goals with the product, while evaluators collect data to uncover design issues. Usability testing has been shown to be quite successful, especially when it's carried out properly. Heuristic evaluation is a little different. It's also known as expert evaluation, and it analyzes the product against a set of human factor evaluation principles. The experts will determine the components of the product that deviate or align with the standards to identify design issues. The authors identified 7 areas of the healthcare delivery system where human factor evaluations can be incorporated to promote patient safety activities. The areas that they identified are root cause analysis, failure modes and effects analysis, procurement, in-house software development, policy and protocol development, training and education, and facility design, which encompasses a large part of a hospital or a healthcare delivery system. By including human factor evaluation into these aspects of the healthcare system, potential patient safety risk can be mitigated in advance of an accident happening, or it could also be involved retrospectively to make enhancements or improvements to existing product design after an accident happens. And it can be used in both scenarios effectively. The second reading I did is it's from Health Systems, the Journal of Health Systems, and it's called Toward Improved Heuristic Evaluation of EHRs. The intent of this article was to examine several well-known sets of heuristics and compare and contrast them in the context of clinical electronic health records heuristic evaluation. So as you know, electronic health records are widely used across the healthcare delivery industry as a means of documenting and ordering and keeping patients' records on file. However, the implementation and adoption rates of EHRs in the United States, as well as in Canada, remain low, and this is due to reports that they often fail to meet user requirements or that the vendors do not reach specific goals. So this is related to usability, and the article points out that usability is a large barrier to meaningful use in the United States. Meaningful use in the context of electronic health records is the use of these EHRs to improve quality, safety, and efficiencies in the healthcare system. The human-computer interface community has often applied recognized sets of heuristics to EHR evaluation, such as the well-known Nielsen usability heuristics for user interface design. However, some healthcare groups have begun to recognize that a set of heuristics that are specific to EHRs may be needed to appropriately evaluate EHRs. This is because EHRs can be quite complex. They also range across a wide spectrum of clinical functionality within the healthcare system, and the importance of personal health information privacy is extremely high. And finally, the importance of preventing errors within an electronic health record is also extremely high because errors could lead to patient safety, patient death even. The authors of this article discuss the theory of fit, which includes cognitive fit and task technology fit. and that they say that it is effective in designing a tool that fits the user in a way that improves performance. The authors believe that the theory of fit can be used in the development of EHR-specific heuristics, and they recommend that future research focuses on working towards developing a set of heuristics that are specific to EHR evaluation. The third article I'm going to be discussing is from Procedia Manufacturing, and it's called Human Factors in the Design of Medical Simulation Tools. So medical simulation was a part of our readings, and I personally thought it was an interesting way to incorporate medical simulation into this course. So this article was a systematic literature review of medical simulation software and the human factor design considerations that are relevant to these types of systems. Medical simulation can be used in many different ways by multiple different user groups within the healthcare system. These areas include clinical training, operational, managerial, and educational simulations, and are all used and important pieces of technology in the medical field. Due to the complexity of simulation tools and the multiple types of interaction simulation encounters within the healthcare system, user acceptance is highly important in designing systems that are usable and reduce risk and error, because again, risk and error in the healthcare system can have very strong implications. In order to focus on patient safety and reducing error, the design of the interface must use human factors to take into account realistic human cognitive, perceptive, and physical capabilities as well as limitations. Without design and evaluation that uses human factors, the author believes that error is unavoidable. The author recommends adopting certain human factors design principles into medical simulation to address some of the challenges with medical simulation interfaces. The recommendations include providing a response to users at every action within the simulation, making the function of the components very obvious so there's no ambiguity as to what each function does, creating messages that are easily understandable by the user and multiple different user groups, minimizing the memory load required by users, and using shortcuts to increase the efficiency of the product. And these recommendations are hopefully going to be used going forward with other medical device development. Finally, I'm going to be talking about an article from the International Journal of Medical Informatics, and it's called Criteria of Interface Evaluation for Computer-Assisted Surgery Systems. So the intent of this research paper was inspired to define standard and effective evaluation techniques for computer-assisted surgery systems. The authors noted that much of the previous literature did not provide human-computer interface frameworks for specifically these types of computer-assisted surgery systems. The research in this paper focused on a software program that was used preoperatively by surgeons to plan total knee replacement surgeries, the interventions for these surgeries, such as the size and the position of the prosthetic being implanted into the patient. The approach used Nielsen's heuristic evaluation method of interface evaluation and consisted of 3 distinct components. The first component was a user satisfaction evaluation of the human-computer interface using a questionnaire. The questionnaire evaluated the subjective feelings of the surgeons, who were the users, about the ease of use using the tools to achieve their aims. So how did they find the software? How was the usability of the software from their perspective? It also used an objective observation of the users by an expert in interface design, followed again by a questionnaire. This expert evaluated objective pieces of the system, including the time required to complete a task, the errors, and the layout of the interface. Finally, an evaluation was undertaken to look at the repeatability of the results as a measure of the program's efficacy. The total knee replacement planning software evaluation used an iterative approach and provided useful feedback about the usefulness of the interface and informed future developments of the design and functionality. The findings of the study have been summarized and may be useful to other research in developing orthopedic computer-assisted surgery systems. That is the end of my annotated bibliography presentation. I hope you learned something, and please feel free to leave comments at the end of this thread.